There is only like one universal language, in our opinion, which is a programming language. And then we actually use HyperMesh as a meshing software to do the pre-processing of the simulations. Most of the time, the guy or the person who actually writes the code doesn't use it. I mean, the bigger the company, the more complex the company structure is. And this makes things more complicated. We try to solve this very complex question with a kind of like a visual programming language. Our idea was, well, that's really tedious work. We are repeating the same stuff. People who are actually not able to convert into a different area, they will not survive.
Moritz, again, welcome to the show. I think a third time already.
Thanks, Jousef, for having me again.
Really cool. So today, let's delve into the topic of process automation, which is kind of, I want to make the analogy of the Zapier for mechanical engineers. But before we jump into that, people who don't know who Moritz is, who are you and what is Synera doing?
My name is Moritz. I'm one of the co-founders, managing directors of Synera. We are a process automation platform for engineers, mainly automating tasks like CAD construction, simulation tasks, and all the ecosystem around it. We are a Bremen-based startup, and currently working mainly with automotive industry and aerospace industry as our customers.
Okay, I think that was the shortest pitch ever. So to the point, really cool. Let's delve straight into it, Moritz. Process automation in general. Why is it actually necessary for engineers nowadays to have process automation in place?
Maybe I start with an own experience which I had when I still was working as an engineer doing projects for I guess it was Audi down the time as something like lightweight design optimization. And well, it started all with actually like gathering of the requirements that those guys gave us, like the eigenfrequencies, the optimization goal, like minimizing mass and the materials and these kind of like boundary conditions. And then we actually started with an ideation process. So sketching, maybe doing some topology optimization set up for getting an idea how the optimal load path could look like. And then we went over to our CAD software. At that time, it was CATIA V5, and we modeled the ribs and the configurations, which were kind of interpreting of the topology optimization results. And then we actually used HyperMesh as a meshing software to do the pre-processing of the simulations. And then we used Nastran for simulation of the physics. And at that point, it turned out that actually our ribs were, not optimal angled, or they were like too thick or too thin. So we went back again into the manual sketches of a CATIA, changed everything there, exported it again, remeshed it again, applied the boundary conditions again, did the simulations again. And at that time, actually, our idea was, well, that's really tedious work. We're repeating the same stuff, like exporting stuff, meshing it, simulating it, putting it back into geometry, analyzing the stress reports over and over again. And we did this, maybe like 10 times, and we improved on the quality of the part for sure, but it took us insanely long. And so, we started to actually use scripting. We used at that time, it's TCL scripting for the HyperMesh. We used some VBA scripting, some C# scripting for connecting to CATIA. It was a mess. It was like somehow the designs that we have built it up were like crashing down 20% of the time. So you could not rely on the optimization goals all the time. And so this is, I guess, it shows also, I guess, which I've heard now from our customers, the everyday work of engineers. So that's actually how engineers are working today. So they are using software tools. The tools themselves, they get better and better and better. But the interlinking of these tools, so the automation and the import and export stuff, it's still super much repetitive manual work. And that's just insane. And I guess it's no fun at all if you have to repeat the same stuff over and over again. You get really bored about this work. And so for me, I guess automation is really, really necessary in this field. And it's not yet there.
Yeah, really interesting that you say that, Moritz. Would you say that even bigger companies struggle with the adoption of kind of a, for example, low-code solution even more because they kind of have the fixed system and processes in place, and it's very hard to disrupt, quote unquote, disrupt them?
Absolutely. I mean, the bigger the company, the more complex the company structure is. So usually you have different departments, you have hierarchies, you have politics, you have experts. And this makes things more complicated because it's not only the tools that are fractured, it's also the people working in different tools. And what I have realized actually is that the older and the more mature a company is, usually also the, let's call it tired, the people are in there and they are somehow hiding behind processes or, like, say, other people's approval. So if you compare it to a smaller company where you still have the responsibility for the outcome at the end yourself, you actually can drive things and you can communicate and you can connect with other tools to speed up processes. But the bigger the company is, the harder this gets actually.
Yeah, I want to talk about two things. First of all, the activation energy to basically overcome this adoption, I would call it tediousness, and then also maybe talking the same language between different departments. But maybe let's tackle kind of the activation energy. So how much, quote unquote, activation energy do you need to actually convince people to use a different solution? Like how much do you need to convince them? End user versus decision maker?
It's two completely different things that you need actually for those two people. So for the end user, you need to prove it. You need to showcase that it's working on a part, on a design, and that it's actually faster than the way the expert is used to do it his own. So that's really this. You have to have this not invented here argument. This has to be done at 100%. So you need to showcase on a technical demonstrator example. And for the managers themselves, they are more open to these, let's call them management arguments, like time to market or cost reduction and these kind of like business impacts that such a process has. And of course, you have to showcase, and this is not so easy, that you have already done this before. So it's like working with examples, working with best practices that you have seen at other companies doing. So it's more and more about these trust building elements, because actually for those managers, that's a high risk to change a system. I mean, they are responsible for the output. They are responsible for the people working, and for them making a wrong decision, that's the super GAU. You need to make sure that you mitigate the risk of actually failing, and that the only case that you can do this is actually building trust and showcasing that it's actually possible. Maybe giving them the possibility to talk to people who have already done this and who know the pitfalls and who know the criteria to success. But that's
interesting.
Arguments.
Yeah, I see. Can you talk a little bit about some of the use cases, some of impressive use cases that you've worked on in the past? Maybe about auto FEA, die casting, utility workflows, for example. Like maybe you can talk about some of those things.
So to give you an example about the die casting world. So usually if you cast a part, the manufacturing process has some very, very specific requirements to the design. So for example, you have to have a drawing angle. So you have to like design the ribs in order to, at the end of the process, to be opened, the tool could be opened, and so that you can actually like deform the part. And also, as it is like liquid metal, if you're using aluminum high pressure die casting, for example, this is a very specific physics if you inject it. So you have to make sure that actually the mold is like running smoothly, and you have to place it at the right angles and the right places. So actually what you want to do is you want to use a simulation of the manufacturing process. We call this like a mold flow simulation, for example, and at the same time design the geometry in a way that it's actually feasible for the manufacturing process. And again, as in my first example, usually this is a linear process. So you design a part, then you try to simulate the physics and the manufacturing process, and then you realize, damn it, in this corner I have some air bubbles, or here maybe it's not so optimal from a mold flow perspective, and then you might change the design. So again, here you're running iterations. So you're changing the design to better fit the manufacturing process in order to improve the quality of the part, but also, for example, to improve the cycle times of the manufacturing process. So you want to get down to a little cycle time, as this gives you more cost efficiencies in the manufacturing process later. And again here, how can you actually achieve this? It's connecting two worlds, the geometry generation, maybe physics simulation, maybe manufacturing process simulation, and you want to have this whole thing automated to, at the end, create a design that is perfectly matching the requirements of the manufacturing process. And therefore, I guess it's, again, necessary to connect those tools and to be able to communicate along those tools and to exchange information.
That makes a lot of sense. A really impressive use case. I was wondering, we have talked about like kind of how it's being done now, kind of the status quo, but how is it actually being done, like using Synera? Because we haven't talked about your solution yet. We only talked about process automation for engineers or mechanical engineers, but how is it actually being done? How do you start from scratch, set up a workflow, and then build on top of it?
That's a really good question. We tried to solve this very complex question with a kind of like a visual programming language. Because, as I said, we used it down the time and actually writing code. We used maybe Python, VBA script. It's working like this, but it's only for expert, I would say, who could all create the code themselves. So we decided to go one let's say, abstraction layer higher, it's a visual programming language. So we are using, call them nodes, which do like mathematical equations, like for example, multiplication or geometric operation like Boolean union or creating lines. So these are like the minimal building blocks of the engineer's work. So our software contains over 1,500 of these nodes that you can connect together. And then you actually can like process them like with inputs and outputs, and you can connect the output of one node maybe to an input of the next node. And so with this chaining up of the nodes, we create workflows, and these workflows then could be processed fully automatically by the computer. So it's kind of like similar to actually writing a cooking recipe. So like just add the flours, then you need 5 eggs. And if the eggs are large, then you need 4 eggs. If they're small, then maybe 8 eggs. And these kind of logics we can digitally model in our like virtual world. We call them then a workflow, a recipe. And yeah, then afterwards you can just click on the button and actually the cake is cooked, or I know the die casting part is optimized.
Yeah, I think it's a good analogy. Also, I think it's nice to imagine that basically it's also a kind of a productivity workflow, right? You build it from beginning to the end, kind of a productivity tool. And then you can basically disconnect from a node, connect with another node. And you also have your kind of what I would call a Synera app store, which is the marketplace. So you could basically, as an engineer, pick from different solutions that exist on the marketplace.
Absolutely. I mean, the results that have been or that need to be generated in these automations need to be identical with the results that you would typically click manual in your tools. So what we want to actually do is use the same tools that the engineers used in their manual world. So we still are using CATIA, or we still are using Nastran as a solver, because we want to make sure that the results are the same. And if you look into one of my special cases is the material cards. So if you have like a crash part in the automotive industry, it's lots of effort to actually get the physics simulation totally aligned with the real world crash tests. So what the automotive industry is doing, that they're using cars, crashing them to the wall, and then having high-speed cameras to measure the deformation of the whole part. Maybe you have seen these kind of like crash videos. Yep. They look amazing. And actually, afterwards, they are trying to rebuild this real world in the physics, in the virtual world, in the simulation software, Elestina, for example, or PAMCrash. And there, you can tweak the parameters for the material properties. And they do this so long until the real-world example actually fits perfectly with the simulation world. And as you can imagine, it's not enough to just run one car into the wall. You need to do this repetitively. And so actually coming up with only the material properties, which is in the end, it's like, I know, text in a text file. It's insane of value, which is inside of these text files. And they are highly protected. And of course, if they're once in the company, also for automation purposes, we want to reuse them. We cannot invent the material properties on a new way.
Mm-hmm. One thing we talked about is kind of the communication bit, which you touched on a little bit in the discussion. So how does low-code facilitate a discussion or communication between different departments so that we speak the same language and mean the same thing?
Really good question, yeah. Let me give you an example. The CAD designers, like the guys who are, or the people who are usually creating the geometry, they are used to geometric file formats, like, for example, STEP, or CATIA CAD parts, or XT files for parasolids. So specific formats which are only like there for representing geometry with the meta information. And if you're then going over to the next department, let's go for the stress department. They are used to files like FEMDEX or Nastran deck. So this is actually like just nodes. It's kind of like material cards. It's boundary conditions, rigid elements and stuff. So it's a whole other world of, let's say, file formats and representing of geometry themselves. And somehow you want to make those two worlds like talking to each other. So you need to have a universal language. And of course, there is only like one universal language, in our opinion, which is a programming language. This is something which actually you can sit on top of all of the different software tools. I would say today, the most used and universal language might be Python, as it's also easy to train and to understand. So lots of the software tools that we're currently seeing in the CAE market are building their Python APIs, and are they having like possibilities to interact with the software over a visual or over scripting language, which we call API. And yeah, that's, I guess, a good opportunity for automation softwares to connect to these interfaces. And low code as a very, very easy to use language might be a good entry start for engineers who have maybe not run through an education of IT or scripting languages. They are used to usually CAD drawings or simulation setups. And we have the experience that they very, very easily and fastly can start with a low-code language.
Yeah, I like that because the barrier of entry is rather low for
Yes.
Synera. What I really appreciate what you guys are doing is the academy, like kind of the learning material that you give to engineers to maybe upskill themselves is really, really fascinating. So basically they can choose different paths, whatever they want to focus on, basically they just can get started. And apart from other startups that only say like book a demo, call us, and we'll set up a meeting to sell you something, people can actually try Synera like for 14 days, see if it's a fit for them, and then if it's a fit for them, they can still reach out to you at the end, right?
Absolutely, yeah. So we are also having a huge education program because I believe that students have to have the opportunity to get in touch with the new software tools, and they're doing amazing stuff. We always have student challenges. The last time with BMW together, creating some nice AI applications for lightweight designs on a trunk, and this gives just like the opportunity to get your hands on the software and the tool. And I think this is crucial, necessary, because if you come up with a new category like us, there is no process automation category for engineers yet. People are not used to actually using these tools in a way to automate their tool stack. You need to experience it on your own. So that's, I guess, necessary, because just showing it on PowerPoint is kind of hard because it's a new thing. You cannot imagine what it's actually capable to. And that's just the way we think it makes perfect sense for us. Yeah.
Absolutely. I want to touch on a very important point, Moritz, which is kind of the transparency aspect. You talked about the crash test, right? And like kind of the material cuts are protected. So basically protecting your own intellectual property. I want to see it also, of course, from the creator side. You can build all these workflows, make them as big as possible, and then run everything. But also from the consumer side. So for example, you're not a Synera champion or a user of Synera. You could still use these workflows and kind of tweak parameters in the web, so to speak. Maybe you could talk about that solution as well.
Absolutely. So again, I want to draw the analogy to a programming language. So if let's assume you're running Python code, most of the time the guy or the person who actually writes the code doesn't use it. He writes it for someone else. And usually what we see on top of the code is a user interface, like some of a nice graphical user interface, like a website or like a Windows application, any kind of this. And I guess the same analogy is also for low code. It's possible. So you have persons who are building up the workflows, the automation workflows. After this tool, connect next tool, then come up with this decision, in the end optimize it, and so on. And we are building up these workflows on the low code environment. But then actually there might be another person, so maybe the manager or another department, which might also have a benefit from using these automation workflow, but they don't actually want to deep dive into the low code language. They don't care. They just care about inputs and outputs, and the rest could potentially be a black box. Maybe it's because it's protected IP behind it. So the person who created the workflow doesn't really want to offer like all the details, how he actually came up with the result. But maybe it's just like simplification. And so we also created some kind of solutions for a graphical user interface for the consumer, as we call them, where they can just like input their inputs. Maybe they upload a geometry or they just enter some numbers, and then they can click on a button in the web. And actually the whole workflow is automated and processed. And at the end, you can get the results out of it. And this is a pretty easy way to then also access expert knowledge. So imagine for one of our customers, they have the simulation department, which typically does modal analysis, so the eigenfrequencies of a design. And at the current stage, the designers who are working in the CAD world, they are requesting over a ticket system, please run this eigenfrequency simulation for me because I need to make sure that my design fits the requirements. And so the design department has a huge backlog, the simulation department has a huge backlog of actually tasks they need to simulate. And again, here they get the geometry, they mesh it, they apply the boundary conditions, and then they get the eigenfrequencies, and then they send the email back with hey, your eigenfrequency is da 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 da. And now imagine that this workflow is stored in a automation and is public, available to the whole company on a website or on any other REST API call, so that the people in the design department can just easily upload their design and then click on a button, and within seconds, they get back the eigenfrequencies in their design and can continue. This really speeds up the whole iteration cycle between those two departments, but still the design department can rely on expert quality eigenfrequency simulations, because the workflow itself is updated, maintained, and created from a real expert. So we mitigate this, let's say amateuric people are using FE simulations, and we are enabling them to access the expert knowledge over a fully automated process.
That's so interesting. I also think it's of or great value, actually, if you use it to maybe pitch your own solution. Maybe a third-party provider pitches their solution to someone else, they want to sell their service to, and maybe they use Synera Run in this case to showcase what they can do.
Yeah, I guess they are opening up very, very interesting business opportunities, also like business models themselves. So you can think about, for example, somebody like creates an automation and he gives other parties access on a pay-per-run model. So yeah, we are exploring this new world. It's completely new to the engineering world. That's at the moment, I guess the only relationships is either sell me a software or sell me your hours in work. And there's no actually, build me a software that actually can do this, and then I pay you by every time I want to have some result calculated. I guess that's typical for SaaS applications. So these cloud applications and these pay-per-run models. It's a new thing, which is so far not very much established in the, let's call it, old-fashioned engineering world, where you need to trust the results and you have these complexity in tools and data models and expert knowledge, which you are trying to encapsulate in these kind of automation workflows.
So I guess the first step that you guys at Synera will be taking is kind of make it available or host Synera Run on an internal server of companies, and then maybe roll it out to things like AWS, for example, in the future.
Exactly, that's our plan. In the first run, our customers also want to have their automation workflows inside of the protected IT environment. So it's all behind firewalls and VPN connections, because actually that's the holy IP of the company, right? So if you're taking a customer of us, for example, BMW, their brand, their design, that's the main asset which they have, and they want to protect it. So they don't ever want to give it to the public, so that potentially another company can just use the same algorithm how they design their designs and then copy paste it. That would not be so nice.
Yeah, definitely, that makes sense. Also, Synera Run, when I launch the application or build the application, do I have to code it? Like, do I have to be a coder, or do I just click in the interface and say, create me a interface of Synera Run, and just it takes the workflow and creates a user interface out of it?
We try to lower the barrier as much as we can. So you are fully able to prepare the workflow in our local environment, and then it's as easy as clicking on a button, really. Literally one button, and then the workflow is published.
That's really cool. Would you be able to tweak it afterwards, like with code? Like I know it's a low-code solution, but would you be able to hijack the workflow with code?
Yeah, you can do this. So we, for example, have like script nodes that you can inject, like Python, C# or any other scripting language. So you can have that's why it's called low code and not no code. So you have still the possibility to inject, let's say, code into the workflow themselves. And of course, you can create. Now it's getting a little bit more in the complexity. You can create hybrid setups. So imagine you have a single. Maybe it goes in the direction of microservices, like input-output thingy, which is on your server. And then you can call this service over REST API in another service. So you can really create a infrastructure of little automation workflows who are all specified to one task, and then create an overarching maybe system workflow for systems design, or overarching optimization workflow, which then can call the different helpers itself. So I guess you're pretty much open to do the most complex setups that are suiting your use cases.
No, that's really, really cool. I talked to Pierre Zabrowski from Dive Solutions I think a year ago or something, and he had the vision of actually having an ecosystem with an app store with different apps of different providers. For example, we could talk about SimScale, Synera, and so on and so forth. What is your vision for the future, maybe for Synera, maybe engineers using the tool Synera? What is the possibility?
I always try to look for Jarvis as a vision. So if you know Jarvis, it's this AI helper of Tony Stark. It's a voice interface which actually Tony Stark is talking to, and then the AI is able to give him advices or create actually engineering tasks for him. And so that's our vision that we want to go. So it's going to be a little helper. And of course, you need to be able to source and connect all the different expert software tools in order to answer a question what is the most sustainable design for my rim? there you need to connect to a software which is able, or to a database which is able to have the sourcing data of the CO2 footprints inside. And so I guess the vision is definitely similar. So you need to have a common layer, a connectivity over all the engineering tools, and you need to have a orchestrating puzzle piece which is able to inject and extract information out of the different tools.
Yeah, I don't want to speak for you, Moritz, but isn't it almost possible? Because you could like hypothetically inject or a user node that's using ChatGPT, and you give it instructions to then maybe create kind of a node or an FE simulation, whatever. But you're very close to it, actually. I'm not sure.
Yeah, we're close. Yeah. Yeah. So I guess it's not like a 5-year vision. This could become true within the next.
Yeah, you don't want to oversell. Okay, that's good. I like this. You're still a startup, but you don't want to overpromise. That's good.
I mean, that's a huge thing. And I guess now with the rise of the large language models and also the ability to cross train them, we have some very, very promising demonstrators. So we try to work in these, let's say, MVPs, test it out on a little data set, and they look fantastic. So like I said, it's not like public yet, but we will get there soon. Yeah.
Yeah, I think Daniel, your colleague, Daniel Siegel, he posted something on LinkedIn, how to use ChatGPT. So I can link it down under this podcast so people can check it out. So yeah, maybe in a couple of years it will be possible. Is there anything else we missed, Moritz, from a process automation standpoint? Maybe something important, some last remarks from your end?
Yeah, absolutely. It was like a very interesting like discussion that I had the other day with one of our customers, and I asked him, is there any solution that you are currently using in your automation stack, tool stack for engineers? And he said, damn it, no. I know what is RPA. So we have these business robotic process automation tools. We also have this tools for process mining, for example, to automate stuff. We're using Zapier in one department. So he knew actually that it's possible to connect tools and to automate all of these tasks, but he had never thought about applying this to the engineering domain. And so I was wondering, okay, why did you try it out, or did you give it any try? And he said, well, yeah, we tried it in a little project, but it turned out that the data complexity that we need to handle and the fragmented ecosystem, it's so much more complex than, for example, connecting SaaS tools or just connecting Office tools, which typically these process automation tools do. And so it was just not capable to convert these kind of automation workflows into the engineering world. And I guess that's just like a really big opportunity for us to leverage on the automation capabilities, which is already known in other business areas. For example, HR tools do this all the time, and also bring it to the engineers. And it will solve so much tedious work. And I hope you also can give engineers some of their, let's say, genius work back and reduce the tedious work, which is just annoying.
Yeah. 2 days ago, I talked to Mike actually on this podcast as well. We talked kind of how the engineering landscape in terms of jobs will change and kind of maybe the ethical policies behind it, etc. How do you think the job of an engineer will change in the future? Will they become more a generalist? I talked to Mike about kind of a pie, like the Greek simple pie. Like you have a couple of areas you're really good at, but still become broad. Like how do you see the engineers will evolve in the future? More generalist, more specialists, especially with the automation?
So I think there will still need to be experts. So if you are automating a process which automates FE simulations, you have to be the expert in this domain, because otherwise you cannot prove that the workflow is the right thing. But the role actually that you're doing will change from actually like running FE simulations day and day and day and day into creating once a workflow, and then afterwards curating the results and maintaining the workflow. If it's still up to date, if it's still getting out like the right results, which you also expect if you do it manual. So you will get into a more quality assurance role. We call it the curator role of the workflow. But still, of course, you need to have the expert knowledge. So I don't see any future where mission critical engineering processes just rely on AI results or anything like this, because there's so much noise and let's say potential failure in these results. And you just cannot rely, not yet. Maybe they will improve in future, but at the moment, I still believe that the quality assurance, the final check, okay, this plane can fly. That's the quality assurance that I, as an engineer, like stamp on the paper. This will be there, I guess, for a long time still in the future.
So we still have the human in the loop approach, so to speak.
Absolutely.
Yes. in terms of job, like maybe jobs vanishing from the market in terms of automation? Do you think that will happen, or is it less likely to happen?
Yeah, I guess they definitely will happen. I guess it's a disruptive technology, and whenever you automate stuff, the people who are actually at the moment just doing repetitive work, and there's with no like intelligence or creative work inside, just like kind of writing stress reports. If somebody's doing this right now, I kind of think that these tasks will get vanished, and the people who are actually not able to convert into a different area, they will not survive.
Yeah. How can an engineer make themselves quote unquote future proof? Like how can they upskill themselves? I mean, we talked about the academy, right? What would be your recommendation, like apart from Synera right now, to basically be bulletproof for the future?
I believe like learning a graphical or learning a language that for programming, like Python, for example, is definitely a good advice. There are so many great getting started tutorials out there, hello world examples. And I guess if you are able to write code, I would recommend Python in this case to start with. You get into this mindset actually of thinking in workflows or in logics, basically, and in objects and these kind of stuff. And I guess this ability to think in programming languages instead of clicking tools, this will help you very, very much in the future, because all the automations, all the digitalization projects out there are somehow related to automation and to kind of scripting and programming languages. So I guess that's maybe the best thing you can do now.
Yeah, that's a good tip. I think even though I have a podcast and I talk to a lot of people, I think you even talk to way more people, Moritz, founders, engineers, and so on and so forth. What do you think some of the skills that engineers lack are missing nowadays that they maybe have forgotten? Maybe engineers from the past, they have it, like, I don't know, coding on paper, whatever, in exams. I don't know. Some of the skills that you think will be absolutely crucial to have, especially when you, for example, apply for a company such as Synera, which is like forward thinking.
So what we hear all the time is that people are looking for smart people. So I guess at the moment, also with the possibility to ask ChatGPT, the real like deep knowledge in a specific domain is available if you know how to look for it. So actually being smart and being kind of like open-minded to new solutions, this is really something which is appreciated, because you need to learn new things every day. And if you're kind of a person who says, well, I'm expert, I don't have to learn anything like more because I already know everything, that's kind of not so nice. So being open and having this spirit of continuous learning, improving, question yourself, try out new things, I guess this is really something which helps.
Okay, cool. Moritz, I think with that, I think we covered everything regarding process automation. Again, if the people want to check out the website, we want to link every relevant link down in the description. Website, Moritz LinkedIn profile. You're on your way to become an engineering influencer. I've heard from someone. So yeah, definitely check out Moritz's profile, connect with him. And yeah, also the free 14-day trial I'll link as well in the description and the marketplace. With that, Moritz, thank you so much. I'm sure there will be a fourth and a fifth and a sixth episode down the line. But yeah, appreciate you being on the show today.
Thanks for having me again, Jousef.
Have a nice day.
You too. Thanks.